Welcome back, everyone. We will continue with the discussion with cognitive frameworks. So, we left on problem solving, planning, reasoning, and decision making. So, in the previous video, we talk about reading, speaking, listening, learning, memory load and passwords, saving and searching files, memory, perception, multitasking, and attention. And most importantly, attention. So now we will gonna discuss how we can combine all of these terms in one demanding cognitive task, such as problem solving, planning, and reasoning and decision making. Problem solving, planning, reasoning, and decision making are process involving reflective cognition. They include thinking about what to do, what the available options are, and what the consequences might be of carrying out a given action. They often involve conscious processes, being aware of what one is thinking about, discussion with others or oneself, and the use of various kinds of artifacts, for example, map, books, pens, and paper. So basically, this involved a conscious effort. So unlike the experiential cognition that is automatic to us. This involved a conscious effort. So kind of like related to recall. Uh, yes, it actually related to recall, such as the recalling long-term or information during a test. Being aware of what is thinking about, like thinking about thinking. So if you are aware of that, like it's about having numbering. Another way to look at it is numbering your confidence on how much you know about something, like in scale of 1 to 10, how confident are you in learning this? So that's another way of being aware. Uh, Discussion with others or yourself, such as when explaining something or like this, a story, it involves a lot of these processes. That's why teaching involves a lot of this because you need to plan your content for these notes, and then you need to teach that by remembering those facts and the use of various kinds of artifacts. For example, map, books, pens, and paper. So it's about using the tools to be able to solve our tasks creatively. Reasoning involves working through different scenarios and deciding which is the best option or solution to given problem. For example, when deciding on where to go on a vacation, people may weigh the pros and cons of different occasions, including cost, weather at the location, availability and type of accommodation, type of flights, proximity to a beach, the size of the location, whether there is nightlife, and so forth. When weighing all of the options, they reason through the advantages and disadvantages of each before deciding on the best one. So another way to think about this is on Mortimer Adler, How to Read a Book. Basically, the last chapter here there is about combining the reference or relationship of the books that you have read, and then another way to think about this is there is multiple ways to learn something. You can look at it as you using tools, and basically, a lot is going on at the same time that you may not be even aware of because of your limited memory. So, for example, when you're doing a task, you're just not dealing with the task, you're also dealing with people, like the emotional complexities of people. And then you also need to like be creative on the tools that you need to use. And also you need to deal with your health problems. It's kind of like a lot of problems at the same time. Todd 2017 pointed out how people tend to select the products they know and prefer when shopping. One possible explanation for this behavior is that human minds have evolved to act quickly, making us good enough decisions by using fast and frugal heuristics. We typically ignore most of the available information and rely on only a few important cues, such as recognizing the name of the brand. Another example for this is that when speaking, we're not aware that we are using another cognitive ability or cognitive consciousness when doing it or when reading something or when listening something, because most of the time the sense or we can only be aware of like vision, hearing, and then touch. Usually, touch senses at the same time. But for a lot of tasks, we are really not aware on how we do things. It's just we need to be conscious to be able to like uh, notice that. Later, we will explain why. So for this, basically, because people have their trusted brands and they don't want to use another. I mean, it's just not that they don't want to use another brand. It's just that it takes time to learn the other brand. And then another thing is that they don't want the uh, time to they don't want to use or spend time looking for other. Another explanation derived from evolutionary theory suggests that searching the shelves in a supermarket is akin to foraging for food in the wild. Animals decide to remain in one patch, wait until they have eaten most of the ripe berries before leaving and seeking a new unexploited patch. Similarly, it is thought that choppers stay with the familiar plant patch before exploring others. The reason is that there can be cost to moving away from the branch, time needed to find an appropriate alternative or to get used to its mess. So that's what I've said. This resistance to change poses challenge to health and sustainability advocates who want to encourage shoppers to switch to healthier options as they may not take notice of new products. Given this proclivity to not see, how might technology be designed to encourage or tempt people to try something different? One possibility is to design novel forms of mobile augmented reality that draw someone's attention to salient qualities in a new product. Basically, there has been research to create a product that allows the novel things to be accepted by using augmented reality app that allows you to check the difference of healthy food and unhealthy food. For example, it could highlight how healthy and tasty a new kind of vegan cheese or how the packaging used is now 100% recycled. The intervention could use tantalizing imagery, which is minimalist so as not to overload the shopper. However, this requires developing AR apps that shoppers or their family members would be tempted to download and try out in the first place. So the knowledge, or here is the image. They use an image that will evoke an emotion to the user. Uh, so this is actually uh, a type of or a way for people to solve those specific like problem, such as not eating healthy food. Howard Gardner and Katie Davis, 2014, suggest how young people at the time found it difficult to make their own decisions because they were becoming more and more risk averse. Often they would first read what others had said on social media sites, blogs, and recommend apps before choosing where to eat or go, what to do or listen to, and so on. However, relying on a multitude of apps meant that they were becoming increasingly unable to make decisions by themselves. Many will read countless reviews, go on numerous visits to colleagues and universities with their parents over several months, study university ranking that apply different measures, read up on what others say on social networking site, and soon, in the end, however, they may finally choose the institution where their friends attend or one they like and look of in the first place. Do you think today's generation and beyond will experience the same, less or more uncertainty when making a big life changing decisions? So, do you think that the students will not rely on social media apps or their friends in making this decision? Unfortunately, based on psychology, the people that uh, be- make decision based on the people they trust or that has authority. So I would suggest you guys read Influence by Robert Cialdini. It help us know how we make this cognitive decision. So as you can see, guys, there's a lot or a million ways to describe these things, but the act of like describing it or like taking notes of it or like just verbally like explaining this or terms is actually helpful unconsciously that help us just like reading as well reading increasingly complex books. You don't notice it at the start, but slowly and profoundly it activates the little your brain. Implications provided information pages that are easy to access for people who want to understand more about how to carry out a activity. For example, web searching. Use simple and memorable function to support rapid decision making and planning. Enable users to set or save their own criteria or preferences. So basically, it's allowing us to edit or custom their list. And additionally, providing like web searching this because this cognitive load, which we will explain later. Use simple and memorable. So for functionality, there's a difference between functionality and uh, and design because like for functionality, it's not design yet. So for functionality, make it simple and memorable. There's a lot of functionality on our websites already nowadays, but the difference is how would you make it simple and memorable so it does not like cognitive frameworks, mental models. Mental models are used by people when needing to reason about technology, in particular to try to fathom what to do when something unexpected happens with it or when encountering unfamiliar products for the first time. The more someone learns about a product and how it functions, the more their mental model develops. For example, broadband engineers have a deep mental model of how Wi-Fi networks work that allows them to set up and fix them. So the more you like these broadband engineers, the more you have a mental model on how these things work. Just like repetition allows you to unconsciously like make it a habit. So another way to look at it is that for like people that started their career doing their job, they are better to learn in their job because they're like brain is still learning. Basically, we our mental model is different for people, but the simplest way I can explain model is about this is the it's about expectation that we have for doing something. So we have an expectation, for example, a website. The website shopping website has a card, a card button. So mental model could also be explained as a system that has a being made to a brain because of how we do every day. So like every day you like access your phone and website. So for people who were born with these computers, they are more likely to learn the technology because they were born with video and mental model compared those old people. So within cognitive psychology, mental models have been postulated as internal constructions of some aspect of the external world that are manipulated, enabling predictions and inferences to be made. This can involve both unconscious and unconscious mental process where images and analogies are activated. Thermostat by switching one hit and keeping it. So basically for thermostat, because like we expect that more is always better. Like whenever we go home and then want to hit it as fast as possible, we think that like turning the heater on our desired like heat will hit the room immediately. But that's not actually thermostat work. Thermostat work is and then until it reaches a certain temperature, it will stop, right? It doesn't just immediately um, put the room in that certain temperature. This process takes time, basically. So that's the reason why do people use erroneous model. What seems to happen is that in everyday life, people develops a core set of abstractions about how things work and apply this to a range of devices, irrespective of whether they are appropriate. Understanding of technologies and services, for instance, the internet, wireless networking, broadband, search engines, computer viruses, the cloud, or AI, work is poor. It has been known for a long time that mental models are often incomplete, easily confusable, and based on inappropriate analogies and superstition. Consequence, people find it difficult to identify, describe, read, or solve a problem, and they lack the words or concepts to explain what is happening. Now, because a lot of these mental models, which is features or like a lot of people are basically illiterate that their understanding would avoid to actually solve their problem. For example, for networks, if you study networks in computer science, there's like 7 layers of networks. So I'm not gonna explain here, but basically, to understand, you have to resolve technical issues. So just like not having so we easily resolve that if you have some understanding of how it works. Additionally, a lot of this technology is as complex so level the book or articles about it because it's counterintuitive with what is used to for thousands of years. How can interfaces develop that help people from determined models? A major obstacle is that people are resistant to spending much money about words, especially if involving an advanced approach is the following: clear and easy balance options, appropriate online help, video tutorials, and context-sensitive guidance for users in the form of online videos and chatbot windows where people can ask how to do something, background information that can be accessed to let people know how something works, affordance of what actions an interface allow. For example, swiping, clicking, or selecting. Appropriate metaphors at the interface. So basically, this idea of design helping people to create a better mental model is reducing our cognitive load by having clear and easy to follow instructions, by providing them resources like video, uh, context article guidance for user, chatbot windows, context chatbot windows, when people can ask how to do something, background information that automatically provide the information So it could be like the wallpaper. Affordances of what actions an interface allow. For example, swiping, clicking, or selecting. Providing tools like being creative. So another thing is that a lot of possible tools that could be on your system uh, actually could not exist yet. So you need to have like this like available tools that's possible for you because a lot of times because of this like complex representations of things, you need to an understanding of a lot to be able to create those tools. So appropriate metaphors of the interface to be able to make sense again. So a lot of happening basically at one time. You are just not aware because your brain and memory is limited. So that's how unaware we are, especially when using these computers. Gulf of execution and evaluation. So basically, as you can see here, what's the current system state? Stale. How do I use this system? So it's about bridging the execution and evaluation. It described the gaps that were assumed to exist between the user and the interface. The goals were intended to show how to design the ladder to enable the user to cope with them. The first one, the gulf of execution, described the distance from the user to physical system, while the second one, the gulf of evaluation, is the distance from the physical system to the user. So this is basically explaining the difference on how usable the system. It just put this in this diagram because for some people, this is like better way to understand this, and also it actually provides this explanation that allows us to have vocabulary on it that allows us to save mental energy. A challenge for designers to find ways of bridging the gaps to reduce the cognitive effort required to perform a task. In many ways, that notions of gulp provide a discourse by which to explore potential mappings and mismatches between how system was designed to work and how person understand how to do a task using it. So basically they are just trying to figure out how to best bridge the gap on how fast the user are using it and how fast they intended to use it. So another thing that I would add to this is that this like invention, like images, videos, these tools are not there, are there for a reason. So we can be creative in using those resources to bridge this gap. But the thing is that we need to like really understand the context on which we are using it. Information processing. So here's an example. Input or stimulant in stage one, it's encoding, and then stage two, you're comparing. Stage three, response selection. Stage four, response execution. So as you can see, based on your input, you need to input it because you're not like a superhero. You need to encode it and then you need to compare it with the information that you have, and then you need to select your response, how you're gonna respond to the situation, and then response execution. So the act of executing the response actually takes cognitive load, which people actually don't notice as much. So here's a human information processing model in 1998. So it's another way to represent our knowledge for us to save vocabulary. Another approach to conceptualizing how the mind works has been used to metaphors and analogies to describe cognitive processes. Numerous comparisons have been made, including conceptualizing the mind as reservoir, a telephone network, a digital computer, and a deep learning network. A metaphor that was popular in the 1980s was the idea that the mind was an information processor. Information was thought to enter and exit the mind through a series of ordered processing stages. Within these stages, various processes were assumed to act upon mental representations. Processes include comparing and response selection. Mental representation were assumed to comprise image, mental models, rules, and other forms of knowledge. So basically, information, it was taught as I remind us to her thought as information processor, like ChatGPT, but it's a different kind of intelligence, right? But it has a sequence on how it processes information. So that's the idea. Within these stages, various processes were assumed to act upon this mental representation. So there's a mental representation for encoding, mental representation for comparison, mental representation on response selection, and mental representation for execution. The information processing model provided a basis from which to make prediction about human performance. Hypotheses were made about how long someone would take to perceive and respond to a stimuli, also known as reaction time, and what bottlenecks might occur if a person was overloaded with too much information. One of the first HCL models to be derived from the information processing theory was the human processor model, which modeled the cognitive process of a user interacting a computer. So here, everyone is the one of the first model that has been created in computer science. So it is used to detect human performance when interacting with this computer. So there's a lot of hypothesis that was created on what is the bottlenecks that might occur if a person was were overloaded with too much information. The model predicted which cognitive processes are involved when user interacts with a computer, enabling calculations to be made of how long a user will take to carry out various tasks. In the 1980s, it was found to be a useful tool for comparing different word processors for a range of editing tasks. A central goal has been to look at how structures in the environment can both aid human cognition and reduce cognitive, cognitive load. So this model it predicts the it calculates how long a user will take to carry out various tasks in 1980. So it's a useful tool for comparing different word processors for a range of editing tasks. Word processors are the most prevalent technology or computer back then. So it was used to look on how it was performing. The term cognitive load refers to mental effort required to learn new information. It is often assumed that cognitive capacity is inherently limited by the availability of working memory resources since 1980, and that therefore designers to keep cognitive load to a minimum, although this clearly depends on the context and activity at hand. So the there was a research back then that says that our memory is actually limited since 1980. So it was the foundation of the design of this cognitive tool. So the if you would go back to the central truth is that our memory is limited. A popular method is the NASA Task Load Index in 1988 that is a simple survey containing six question items that use like ERT skills for the following dimensions: mental demand, physical demand, temporal demand, performance, effort, and frustration. Or it has been used mainly in human factors, studies of aviation, healthcare, and other social technological domains. So, the useful here, how mentally demanding was the task, how physical demanding was the task, how hurried or rush was the pace of the task. So here is important question. How successful were you in accomplishing what you were asked to do? How hard did you have to work to accomplish level of performance? And this is here how successful. It's also important. How insecure, discouraged, irritated, stressed, and annoyed were you? Here is also an important three of the most important third of the most important. The three external approaches we consider next are distributed cognition, external cognition, and embodied cognition. All consider how external structures may support cognition. Distributed cognition, most of cognitive activities involve people interacting with external kinds of representations such as book documents and computers and also with each other. For example, when someone goes home from wherever they have been, they do not need to remember the details of the route because they rely on cues in the environment. For instance, they know to turn left at the red house right when the road comes to a T-junction and so on. Similarly, when they are at home, they do not have to remember where everything is because information is available as needed. So this basically because you have learned to like notice the cue in the environment, so you don't need to remember going home. So that's part of this distributed cognition. Likewise, people are always creating external representation for a number of reasons, not only to help reduce memory load and the cognitive cost of computational tasks, but also importantly to share information and knowledge with others and extend what they can do and allow them to think more powerfully. So we create this mental model or extension of our abilities to be able to explain it to others. So this here, an example of a mental model. This notes is a mental model that we create for us to be able to explain it to others. So we always are creating these cues to help us with our task because without this, it's hard like to accomplish a lot of things. The distributed cognition approach was developed to study the nature of cognitive phenomena across individual artifacts and internal and external representation. Typically, it involves describing cognitive system, which entails interactions among people, the artifacts they use, and the environment in which they are working. An example of cognitive system is an airline cockpit where top-level goal is to fly the plane. The pilot captain and air traffic controllers interacting with one another, the pilot and captain interacting with the instruments in the cockpit, the pilot and the captain interacting with the environment in which the plane is flying, that is the sky, runway, and so on. So here's an example. So this picture represented or another representation of this different representation of knowledge, such as the pilot, captain, and air traffic controller interacting with one another. So another representation or of information is the pilot and the captain interacting with instruments in the cockpit. So it interacts with the instrument. The pilot and the captain interacting with information in which the plane is flying. That is um, the sky, runway, and so on. So this interacts with the environment, like in the air, right? So there's different ways to look at things, but it's important like to represent it as a model, like that, and also to have a reason why you have these models and relationships, because like simplicity or that reason or relationships with our existing knowledge again help us to memorize help it to be memorable. A primary objective of distributed cognition is to describe this interaction in terms of how information is propagated through different media. This means how information is represented and re-represented as it moves across people through the array of artifacts are used, for example, maps, scribbles, spreadsheets, and spoken word during activities. These transformation of information are referred to as changes in representational state. So I would say that, for example, for business, I mean, on your job, you could be working as a telecommunications engineer that has different representation for the network. It could be in physical layer, TCP application layer. So another layer on how to look at it is in the sales side layer and administrative side of your business. Basically, those are reasonable representation because those are really connected to how the world works. So like proven science as well on how this business works. So uh, in the cockpit example, information is transformed through different media over the radio, through the pilot, and via change in the position of the instrument. Analyzing how information flows through a system in this way can be helpful when redesigning an aspect of a cognitive system, such as display or socially mediated practice. It can draw attention to the importance of any new design, needing to keep shared awareness and redundancy in the system so that both the pilot and uh, the captain keep in sync with each other about the changes in altitude that are occurring. So basically, you need to always redefine this representation on how you use the system. For example, in business, like you need to look how your recruitment process works, how your training process works, how your administration process works, how your sales process, and you need to have a system that keeps iterating and resolving those problems. Because system can never be perfect, so we need to always look on the improvements. And also another representation is that's why the feedback representation is useful. If you haven't read no feedback, basically it's about providing the feedback for improving the system, but doing it the right way, like knowing the other person, empathizing with each other. So that's um, another way. So it's also the basis for DCOT analytical framework that has been uh, developed specifically found their standards on healthcare. So I'm gonna go back, guys. Bye for now. Thanks.